Hello all, welcome to my lecture. This is Seshma Chaudhary, working as an assistant professor in Computer Science and Design Department from St. Martin's Engineering College. Our topic in computer graphics is basic transformations. Okay, so in computer graphics, not only displaying images and pictures, with using mathematical equations, you can produce dynamic visualizations. Okay, you can create not only 2D and 3D objects also we can perform. So for that, what we are using, some basic transformations. Okay, applying moves or rotating, these are possible with transformations. What is transformation? Transformation means changing the images. Okay, so basic transformations are rotation. So what is computer graphics? Computer graphics is an art of drawing the images. Okay, now in present it is existing and rapidly growing in computer field. It is a subpart of computer science. Okay, so in computer graphics is a use of computer to create and manipulate display images. Okay, it is a subfield of computer science that combines the design and program. So computer graphics includes 2D and 3D graphics. Computer graphics can be represent the 2D two-dimensional images and three-dimensional images. Okay. Next, image processing. Computer graphics can include some techniques for processing the images. So computer geometric transformations in computer are need to give an entity the need position, orientation, shape, and from existing orientation or shape. So the basic transformations are, we discussed scaling, rotation, transformation, and sharing transformation. Okay, and other type of transformations are projections and mappings. We will use homogeneous coordinates also for these basic transformations, because with this homogeneous coordinates you can perform more than one transformations at a time. Okay, so what is homogeneous coordinates? To perform a sequence of transformations such as translation followed by rotation and scaling, and we need follow a sequence of process. What is the process? Translate the first coordinates, next rotate the translated coordinates, and then scale the rotated coordinates to complete the composite transformations. So we discussed basic transformations in 2D or in geometric graphics. Translation. Okay, so what is translation? We are moving the position of the point or position of the any object, any image. Okay, here one example is there. In the XY plane, we are changing the position of the point. Here the original point is Px comma y, and after changing the position of the point, the translated point position is not denoted as P dash a point. Okay, now what is the geometric equations after translation? So x dash is equal to adding the translated point in x-axis, that is x plus tx, and translation point y dash is equal to y plus ty. These are the equations of the translated point of x dash and y dash. Okay, here we have used two coordinates tx and ty. Tx means translated towards x-axis and translated moving towards y-axis. Okay, here what is translation? Translation moves an object to a different position on the screen. Okay, so we are changing the position of the point. So after finally we can write it as P dash is equal to P dash is equal to P plus T. Okay, adding the translated point to the original point. Okay, next, rotation. What is rotation? We are moving the image in a circular path. Okay, so observe that XY plane, this in this XY plane, the angle is denoted as theta and pi. Okay, So this pi is original angle, and after rotated, the theta angle is rotated angle. Okay, so now the point P is rotated in a circular path denoted as point P dash. Okay, the original angle is phi, and after rotated, the angle is theta. Okay, so in what is the definition? In rotation, we rotate the object at particular angle theta. Okay, so what is the angle we are using here? This is uh, denoted with C. Here cos theta is equal to adjacent side by hypothesis. Okay, and here denoted as sin theta. Sin theta is opposite side by hypothesis. Okay, here we are using two angles theta and phi. Okay, cos theta is r into, okay, so here matrix representation of the angle is cos theta minus sin theta and sin theta cos theta. Okay, next, scaling. What is the scaling? Scaling is changing the dimensions of the object. Okay, so to change the size of an object, scaling transformation is used. Okay, to change the dimensions of the object, we are using this scaling transformation. Okay, here we are using two coordinates sx and sy. Okay, we are multiplying these coordinates with the original point in scaling transformation. Okay, so after applying this scaling transformation, the point x dash is equal to x into sx, multiplying with the scaling of x. Okay, here y dash is equal to y point sy. Okay, here sx and sy are the coordinates. Okay, finally the equation is p dash is equal to p into s. Okay, here what factors we are used? Sx and sy, and multiplying with the original point x and y, then we will get the scaling transformation point x dash value and y dash value. Okay, next, so next this is reflection. Okay, so what is reflection? In reflection, we'll produce the mirror image of the object. Okay, observe this image. Here we are reflecting towards x direction. Okay, this is the original image, and after reflecting, we will get the mirror image of that object. Okay, so here we are, this is the original image. It is reflecting towards y axis. Okay, y direction. Okay, so reflection will produce the mirror image of the original object. Okay, and this rotation operation with 180 degrees. Okay, so in this, we are in reflection, we are changing the size of the object. Okay, next, what is sharing? Sharing transformation is, we here original point is for x and y, means we are sharing is two types. Okay, x sharing and y sharing. In two directions, we are increasing the shape of the, changing the shape of the image. Okay, so here a transformation that slants the shape of an object, it is called the sharing transformation. Okay, we are changing the object towards x direction or y direction, or you can change the in xy direction also. Okay, that is denoted as sxy. Okay, so sx is sharing the object towards x direction, and sy is sharing the object towards y direction, and sxy is sharing in a plane, both x direction and y direction. Okay, we are shifting the coordinates. If in x direct, in x share transformation, we are preventing the y value and we are applying the share transformation to the x. Okay, and next, see, observe this image. This is original object and this is after sharing object. Okay, here the coordinate is towards moving towards x direction. This is x sharing. Okay, so the x share preserves the y coordinate. In x share transformation, we can preserve the y coordinates and we are applying the sharing transformation to x coordinate. Okay, so the equation is x dash is equal to x. We are preventing this x value and applying this sharing transformation to y value. After applying this sharing transformation, the equation is y dash is equal to y plus shy into x. Okay, next, so next, so these are the next y dire. So y, this is y share transformation. So in y share transformation, see, this is y share transformation. Here we preserves the x coordinates and changes the y coordinates. Okay, so finally you will get the sharing transformated image towards y direction. Okay, in x direction it will move right, the image will move right to left. In y sharing transformation, the image will move top to bottom. Okay, next, composite transformation. Okay, so here we'll use two transformations, T1 and T2. Finally, you can multiply with two transformations, you can get the this composite transformation. Okay, the equation is T is equal to T1 into T2. Okay, so what is composite transformation? The combination of transformations. Okay, with the combination of transformations, you can multiply this all transformations, you can get the composite transformation. Okay, so these are the final basic transformations. Okay, so these transformations are basically two types: geometric transformations and coordinate transformations. Okay, so now we saw the geometric transformations. What are the geometric transformations? Translation. Okay, translation means moving the object, changing the position of the object from one place to another place. Okay, you can change the points and then after join that two points you can get the image. Okay, you can you can get the lines, you can get the polygons, polygons you can use. Okay, you can apply these translations to any geometrical shapes. Okay, with you can create any circles and lines, all in polygons, rectangles, and you can change the position of the object. Okay, then what is then you can apply the rotation, reflection also. What is rotation? You can rotate the object in a circular path. Okay, applying some angles with 180 degrees. Okay, next, what is reflection? The image will reflect in x direction, that is opposite of the direction, and you can reflect that image in y direction also. Okay, next, so basic transformations are, now we saw the translation and rotation and reflection. Reflection is what? Producing the mirror image of the object. Okay, and finally sharing transformation. Sharing transformation. Okay, these transformations are two types: geometric transformations and coordinate transformations. These all are geometric transformations. So what is a translation? Moving the position of the object from one place to another place in a xy plane. Okay, so what is a reflection? You can produce the mirror images. Okay, and then what is rotation? You can rotate the object in a circular path. And finally, what is sharing? Sharing transformation is you can make the slant size of the, you can change the shape of the object. Okay, sharing transformation is two types, x sharing transformation and y sharing transformation. Now we saw that two types of sharing transformations. Okay, now we can create 3D objects also. Okay, what is this 2D and 3D? These are two-dimensional images and you can create three-dimensional objects. Okay, so the process of converting these 2D objects into 3D is called a projection. Okay, here projection, you can project the images. Okay, now in 3D also same basic transformations you can apply to 3D objects also. Okay, so 3D transformation involves mathematical operations. Okay, so with that mathematical operations you can change the size and position and any orientation of the object. Okay, so the main aspect of computer graphics is you can create the realistic images, graphics. Okay, next, see, in 3D transformations also translation, scaling. So translation is the, what is translation? Is the process of changing the position of the 3D objects in a 3D plane. Okay, what is the difference? This 2D and 3D. In 2D we will use direct vector objects. Okay, like circles, you can apply it to circles, polygons, okay, rectangle, ellipse. Okay, in 3D we will take the depth of the image, layers. We'll take the different layers in that object. Okay, so we can apply these transformations to the 3D objects also. So translation is applying to 3D objects to change the position of the object. Okay, so what is the final representation? You can represent this 3D objects in a matrix form. What is the equation of that matrix form? P dash is equal to P plus, here three coordinates we took. Okay, why? Because it is a 3D plane. Okay, 2D plane means only x direction and y direction. In 3D plane, x direction and y direction and z direction. Okay, three planes we will use. So three coordinates we take here. So adding that three coordinates dx, that are dx and dy and dz, direction, x direction coordinate, y direction coordinate and z direction coordinate, that coordinating point adding to the original point, you can get the translated point. Okay, next, scaling. What is scaling? Scaling is you can change the size of the object. Okay, in a 3D space. So this scaling transformation, again the original point is, take the original point as p, x, y, z, and after scaling p dash is equal to p into s. Okay, s is, you know, scaling point, that is x dash, y dash, z dash, and rotate 1. So multiplying this scaling point with the original point, you can get the scaling transformation point, that is p dash. Okay, next, and what other geometric transformations you can apply to the 3D objects? Rotation and sharing. Okay, what is rotation? It will change the orientation of the object. Okay, or see, this transformation can represent the matrix also. Okay, rotation matrix. Okay, here we can apply the some angles, sin theta angle and cos theta angles. Okay, you can represent in a matrix format. Okay, next, sharing transformation. Okay, this is also involves slanting the, changing the shape of the 3D objects. Okay, next, you can represent a matrix form in a column matrix form, you can use, and row matrix form. Okay, here sharing, after applying this sharing transformation, the points are, the equations are x dash and y dash and z dash. You can add that sharing transformations to in x direction with x, in y direction with y, in z direction with z. Okay, so these are topics in basic transformations. Okay, so finally in computer graphics we can apply this transformations. Okay, what are the transformations we have observed here? Translation, rotation, reflection and sharing. These are mainly basic transformations in computer graphics. Okay, so what are the classification of computer graphics? Two types, geometrical transformation and coordinate transformation. Okay, next we'll see the video. So it is translating object from one position to another position. Okay, so these are basic transformations. Next, rotation. About rotation, it rotates the object by some angles in a clockwise direction, or you can rotate in a anti-clockwise direction. Okay, around x-axis and towards y-axis. Next basic transformation is scaling. Okay, scaling, it reduces and increases the size of the object. Okay, so translated points are x dash and y dash. Okay, x dash is adding the translated coordinate tx to point x and adding coordinate point ty to y in y translated equation. Okay, so these are the relationship between the old coordinates and new coordinates. Okay, so this is translation. Okay, we are apply to vertical displacements. Okay, so displacement along positive x-axis means that is positive displacement, otherwise negative displacement. Okay, so same is true for vertical displacements. Okay, so you can apply the displacements along x-axis. Okay, x-axis means that is positive displacement. Okay, next transformation is rotation. Okay, so rotation involves in a angular displacement. Okay, so you can move the point from one position to another position in a circular way, circular path. Okay, so rotation, you can use angle 180 degrees like that. You can rotate towards x direction or y direction. Okay, so it moves the position of the image or object in a circular path. Okay, so rotation, we assume rotation around the z axis in a clockwise by an angle. Here we are observing two angles, theta and phi. Okay, so this is after rotated, the angle is denoted as pi. Okay, before the angle is theta. Okay, so position. Okay, so denoted as theta and pi, we used theta is original angle and after rotated the angle is pi. Okay, so this is the original point x and y. After rotated, the rotated point is x dash and y dash. Okay, so here this is considering as hypothesis. Here we are using cos theta and sin theta. Cos theta is hypothesis by adjacent and sin theta value is opposite side by hypothesis. Okay, next scaling. Scaling, the given point x and y means multiplying the scaling with the scaling coordinates, that is sx and sy. Okay, see, so multiplying with the original point, this with the scaling in x direction. Okay, so the equations are x dash is equal to sx into x and y dash is equal to sy into y. Okay, multiplying this scaling coordinates sx and sy with the original points x and y. Okay, we can change the, in scaling we can change the dimensions of the image. Okay, we can change the dimensions and size of the image. Okay, how to apply this scaling transformation? Adding coordinates sx and s, multiplying coordinates sx and sy to the original point x and y. Okay, so this translation and the scaling transformations you can apply to the object. Okay, next this is scaling transformation. Okay, so we can call it as uniform scaling. Same scaling factors we'll use for both x and y directions. Okay, so it is a uniform scaling. Okay, otherwise it can call as differential scaling. Okay, so same scaling factors for the both x and y directions, that is a uniform scaling. Okay, otherwise it is a differential scaling. Okay, now you can scale the object up and down, or you can scaling the scaling transformation to right and left. Okay, see, apply this scaling on its surface point with the scaling factors greater than 1 and sx is greater than 1 and sx is sy is greater than 1. Okay, you can okay, so this is scaling. So scaling factors is less than 1, sx is less than 1 and sy is less than 1. Okay, means the point is on the object, the point is out of the object. Okay, so now finally sharing transformation. Okay, we can move towards x direction and y direction. Sharing may be repositioning the object. Okay, geometric transformations. Okay, so geometric transformations are translation, okay, rotation, reflection and shear transformation. Okay, so these all transformations you can apply to 3D objects and 2D objects also. Okay, so in translation you can change the position of the object. We can change the position of the object. Okay, so for example, the object is here. After the translated object, we can change the anywhere in a plane. Okay, then what is rotation? You can reflect the image. Okay, we can you can rotate towards x direction or y direction. Okay, now what is reflection? It is mirror, it produces the mirror image. Okay, this is original image and it will produce the mirror image. Okay, next, what is sharing transformation? Sharing transformation is two types. Okay, x sharing transformation and y sharing transformation. Okay, in x sharing transformation, for example, take the object. Okay, in x share transformation, you can take the coordinate and change towards x direction. Okay, next, in y sharing transformation, you can change the object towards y direction. Okay, these are the basic coordinate points. Okay, in a x y plane. Okay, so these are the basic transformations in computer graphics. Thank you.